One variable statistics standard deviation. Like the interquartile range and the range, standard deviation is a measure of the spread of the data. So how spread out is the data? The standard deviation is calculated on normal distributions. That's distributions that look like this, remember, that have that hump in the middle and are symmetric. And when we talk about these distributions and standard deviation, we use mean as the measure of central tendency. So thinking about the center, we use mean, not mode. If we smooth out the bars in our histogram, we can think of the data like a curve. So if we take these bars and we make them into just a curve like this, smooth it out, it'll look like that, which you can also see right here. This is the same idea. The flatter the curve is, the blank the spread of the data. So if the curve is flatter, like this, then the data is spread out more. So the larger the spread of the data. The more squished together the curve is, the smaller the spread of the data. So if it looks like this, then the spread is smaller. Regardless of the shape, the standard deviation is a number that tells us about the spread of the data. When the standard deviation is large, the data is spread out. When the standard deviation is small, the data is squished together, for lack of a better description. The mean is always in the middle of the data. So the mean we can think of like right there, right in the middle, and right there. Remember, mean is X bar. That's how we can, what symbol we can use to represent the mean. Approximately 68% of normally distributed data is within blank of the blank. It's 68% of the data is within one standard deviation of the mean. So if we have the mean here, notice that this says 68% of the data goes from here to there. So this is -1 standard deviation right there. This is +1 standard deviation, and that's -1 and +1 from the mean. About blank of the data is within 2 standard deviations. Well, if we look right here, this is 2 standard deviations, and it's 95% about. So this is -2 standard deviations. So that's 2 standard deviations below the mean. And here's 2 standard deviations above the mean. So about 95% of the data is within 2 standard deviations of the mean. And almost blank of the data is within blank standard deviations of the mean. So if we look here, again, from here to there, 99.74% of the data is within 3 standard deviations of the mean. So this is 3 standard deviations below and 3 standard deviations above the mean. So almost all of the data is within 3 standard deviations of the mean. Lots of naturally occurring phenomenon, like height of humans, is normally distributed. So if we look at that histogram at the right, it's about the height of humans, and it's pretty close to normal. And we often say that data is normal, even though it's not perfectly normal. It's relatively normal. From the information in the histogram, we know that 68% of the data lies between blank centimeters and blank centimeters. So 68% of the data is one standard deviation below up to one standard deviation above the mean. So we can look here and we see that the mean is 165 centimeters. So right here is 165 centimeters, and that is the mean. So one standard deviation below the mean and one standard deviation above the mean will contain 68% of the data. So what we can do is we can take the mean, 165, and subtract one standard deviation. So we take the mean, 165, that's the mean, and we subtract one standard deviation, minus one standard deviation, and we get 160. And so I'm going to put that in purple. And so right here, 160 is one standard deviation below the mean, up to one standard deviation above the mean. So now we take the 165, which is the mean, and we add to that one standard deviation, which was 5, so plus one standard deviation, and we get 170. So again, we know that 68% of the data goes from one standard deviation below the mean up to one standard deviation above the mean. So that right there is about 68% of the data, almost 70%. 95% of the data lies between blank centimeters and blank centimeters. So we're going to do something similar here. We're going to ask ourselves, all right, well, if we take 165, the mean, and we add two standard deviations, so we add 10 because 2 times 5 is 10. Oops, we subtract because we're going below at first. So minus 10, that's 155. So we're subtracting two standard deviations. And so now I'm going to do that one in orange. So it goes from 155. Whoops, that one should be here. And then adding two standard deviations, 165, that's the mean, plus two standard deviations is up to 175. And so what we can do is we can say, all right, from 155 right there up to 175 right there, that contains 95% of the data. And what that means is that approximately 5% of data is out here. And almost all of the data lies within 3 standard deviations of the mean. So notice that we are just subtracting 5 here for each standard deviation, which takes us to 150, or adding 5 for each standard deviation, which takes us to 180. And that is the general idea of standard deviation in one variable statistics.